they want us to find Jm. So finding x there, right? Okay. So we have, what type of object? Is that a interior altitude or is it a leg? It's a leg. Okay. So legs are the geometric mean, right? So 3 root 6, 3 root 6. There you go in those spots right there. Okay. Now it's the leg between the whole hypotenuse, right? What would you call that whole hypotenuse? X plus 6. And then the portion of the hypotenuse that is touching the leg that we used. So that would be 6, correct? All right. I'll let you cross multiply and do the work here, but I will help you with these because I think that might be algebra that we need to revisit. If I'm multiplying radicals, and I'm just going to write a generic version of this over here. If I have A radical B times C radical D, the process of doing the multiplication is that you take A and C, and you multiply them together, they stay outside the radical. And then you take B and D, and you multiply them together, and they stay on the inside of the radical. That's the general practice for multiplying radicals. Is that doable? Okay. So when I do that with 3 radical 6 and 3 radical 6, okay, my A and my C, that's A, and that might be my C. They can be the same number. So what's 3 times 3? 9. So I go 3 radical 6 times 3 radical 6 gives me 3 times 3, and then underneath it gets 6 times 6, right? So you told me that was 9. What's 6 times 6? 36. What's nice about that number? Perfect square. So this is really 9 times what? 6. 9 times 6 is 54. So there's your cross product of 3 and radical 6. Now, some of you might not like doing it that way. That's fine. Do you know that 3 radical 6 times 3 radical 6 is this? Okay. And when we have AB, now I'm going to write it this way. I'll just give you another generic rule here. Law of exponent says if I have A raised to the M, B raised to the N, and then I raise all that to the R, because remember that what you do is you take A to the MR, B to the NR, and that basically just tells you multiply the exponents. Well, right now these exponents are 1s. Okay, so I get 3. 1 times 2 gives me 2, so there's 3 squared. And I get radical 6 squared as well. A couple different ways we can actually view that, but what's 3 squared? 9. What happens is power 2 and the square root. The words escaped me there for a minute. They cancel. It gives me 9 times 6, right? Still 54? So there's different ways of viewing it. It's ultimately up to you. Okay, whether you use the exponent rules or you use the multiplication of radicals rule. Is that all right? Any other questions? Number 6, JM is 3, JL is 6, find MK. Okay, so let MK be X. So, which one's the of the parts that they provided? Which one's the geometric mean? 6. Okay, because that's the leg, right? Okay. Now, if a leg is what you're using as your geometric mean, then it's the geometric mean between the what and what? Am I right? Or tell me what I should put here. 3 plus x. So it's the whole hypotenuse, right? And now, what should go here? 3. And that should solve for x for me. Before I go beyond any further, I wrote this on the whiteboard the other day. I was working with somebody today during Wildcat time. Won't mention his name. Not a big fan of him. Tyler Burkholder. But in talking with multiple people, I think people appreciate this and like this, okay? Part of the hypotenuse divided by altitude equals altitude divided by the other part of the hypotenuse. And then if you're using a leg as your geometric mean, then for part of the hypotenuse, sorry, I wrote that, I just cut and pasted for me. Thought I had adjusted this, but I guess I didn't. This should say what? What should that word become? Whole hypotenuse. And what should go here? Leg. What should go here? Leg. Come on. And what should go here? Part of hypotenuse.
Is that right?
Yeah. Touching the leg that you were using. Okay. So if you know those two kind of word equations, they're going to get everything in the right spot. Okay. Now you have to understand what part of a hypotenuse looks like. Okay. You have to understand what the whole hypotenuse is and what part of the hypotenuse touching the leg is. And those are just recognition things that I don't know that I can show you or teach you any more than just showing it to you, right? And you being able to eventually recognize those components. But that might be something that you guys want to write down. And write it down multiple times. Okay, write it down just once. Is that going to help you remember it for Friday?
No.
Probably not. Okay. Are you going to be giving it Friday?
Yeah.
I'm going to give that to you?
No.
No, I'm not giving that to you. Okay, so make sure that you know that and you have that. All right, so let's get back to the worksheet then. All right, looking at some of these. Number 10. I think number 10's one that we can appreciate. Let's look at Z. I just want to find one of these. I'm not going to do all three. We'll just find Z. So what kind of segment is Z? It's a leg, right?
Yeah.
So that should be here and here, correct?
Mm-hmm.
Now going back to what this said, let me just cut this out so we don't have to jump back and forth all the time. All right, so look at what this thing says. We've got Z and Z because that's a leg, right? So that spot and that spot became Z. Now we're looking for the whole hypotenuse, which would be this thing here, right? All the way across. I'm just going to do this first. How do I get that whole hypotenuse? I would do what operation with those two numbers? Come together. So I'm going to write it that way. So whole hypotenuse, okay? And now this is part of the hypotenuse that is touching that leg. So what part is touching the leg? 1/3, okay? How do I add fractions? Common denominator. So what was that, 1/3? It's going to become 2/6, right?
Yeah.
What's that add to? 3/6, which is 1/2. So I'm going to rewrite this as 1/2. Okay. Now, and this is, guys, this is why I've been telling you throughout the whole year, deal with fractions, work with fractions. Because at this stage, we cannot take our calculator and see what the exact value for z is. Our calculator is just going to round it to a decimal for us. Okay? I want the exact value. So what we're going to take z times z gives you what? Z squared. Now, when I take 1/2 times 1/3, how do you multiply fractions? Numerator times numerator, which would give you 1, right? Then denominator times denominator, which would give you 6. So now what I got to do? Square root it. So I get that, right? Okay. We don't like leaving fractions underneath radicals. So here's a little bit of old math for us that might, for someone who seem like new math. We don't like taking radicals of fractions. And this is the reason. We know that this, just like we could do with products of two numbers, we could separate them in their own radicals, right? Well, quotients, we can do the same thing. And it's ultimately for the same reason. The same algebra tells us why we can do this. Okay? So we get that. Well, that 6 in the bottom, that radical 6, that's an irrational number. Does that make sense? Meaning that its decimal place it never ends, or the repeating part, or the decimal portion is what I'm trying to say. The decimal portion never ends, and it never repeats. Okay? It's irrational. We don't like leaving answers with that kind of number in the denominator. Okay? And it's ultimately because there are times where if we get it out of the denominator, it will make the answer look so much better. Okay? And then eventually, if we need to take that answer and work somewhere else with it, it's a better number, better format of the number to use. Much like if I had, 8/4 as an answer, and I got to do division or multiplication with that later on. Wouldn't it be so much easier to do that multiplication or division later on if I took 8/4 and rewrote it as 2? Okay? So root 1/6, we're going to want to transform that a little bit. And this is the way you do it. Okay? This is an irrational number. We want to make it become rational. Rational meaning anything that is written as a/b, where a and b are integers. Okay? So essentially any whole number or fraction that you can imagine. So we want to take an irrational number and make it rational. We call that rationalizing the denominator, because your denominator has become a rational number. Does that make sense? The way we do that is we multiply by 1. Okay? But it's a convenient form of 1. Whatever this radical here on the bottom is, you need to multiply by that over itself. Is that still 1?
Yeah.
It's just a convenient form of it, right? The reason I call it a convenient form, going off what we talked about earlier, what's radical 1 times radical 6? Radical 6, right? Okay. What's radical 6 times radical 6? Radical 36, which is 6. So you see how multiplying by itself, we create that perfect square? And you will always do that. If it was a 12, I go radical 12 times radical 12 gives you radical 44, 144, which is 12. If it was 8, or radical 8 times radical 8 gives you radical 64, which is just 8, right? Every single time I'm taking that number in the bottom and I'm multiplying it by itself to make it a perfect square. So it rationalizes. Now 6 is a rational number because 6 can be written as a fraction, right? 6/1. It has a terminating decimal or a repeating decimal, in this case, a terminating. So radical 6/6 is a better answer than root of 1/6. Is that doable?
Yeah.
Okay. So you'll want to be able to do that same type of thing in some of these other four. I think you might do the same thing in solving for x and y. Okay. I think let's look at 14 quickly. Huh? You got it now? Good. Good. All right, so if we look at 14, let's just set up a proportion for y. Because y is a leg, correct? So I should put the whole hypotenuse here. What should go here then if I had the whole hypotenuse?
X plus radical 2 and then radical 2?
Ah, close.
X.
X. Okay. Now, huh?
Why can't it be radical 2? I get it. Whatever I said then.
Because the similarity statement that generates these proportions is relating or dealing. It's not a direct relationship between that segment and that segment. Those are the things that get related in the similarity statement, okay, or they get discussed in the similarity statement. So it has to be the blue segment being the geometric mean, and then between the entire hypotenuse and then the part of the hypotenuse that is touching the blue segment. This, because essentially what we're doing here is we're comparing, let me look at, we want to compare this blue triangle, the biggest triangle up there, to that green one. Does that make sense? Okay. That's what the similarity statements will compare. Well, if I use that red segment is part of this top triangle, which we're not using as a comparison right now. Okay. All right, so now looking at that, we could do the cross multiply now. We get y squared equals x squared plus x radical 2. I don't know if that's the best thing for you to do right now. Okay, you can, but hopefully you recognize there's two variables there, right? So can I solve for either of them right now? No. So I'm going to go look at another proportion. I'm going to go look at that one there, which is z, right? So z goes there, z goes there. What would z be the geometric mean between? What could go here? X. And what's going to go here? Radical 2. So that is showing that that red segment is always the geometric mean between the blue and the green. Okay? So that is a comparison. When we use that one, we're comparing triangle 1 here to triangle 2 and saying that those two triangles are similar. Okay? What allows me to then find some other stuff here. And I guess looking at that, there's two variables there, correct? All right, so I can't really solve for anything, and I don't want to write z squared is equal to x radical 2. I don't want to do that algebra yet because there's something else that we can do that makes it a little bit simpler. We have looked at that leg. We've looked at that altitude. Now we've got to look at that leg there, right? That is a geometric mean. And this is a situation where people, for some reason, want to always put x there where they put 2's. Okay? Because you're trying to solve for x. And I think you think that, or generally people that miss this think that your variables always go in the means location. They don't. It's just with a lot of the problems that we see, they might show up that way just the way they were designed. But the 2 is what goes there. The legs, thinking back to this, the leg is what goes in the geometric mean location. Hold on a second. So what should go? What would I call that there? X plus radical 2, right? And now what should go here? Radical 2. Remember, it's always the portion of the hypotenuse that's touching the leg that you used as your geometric mean. All right. How many variables does that thing have? 1. So can we solve for x there?
Yeah.
Okay, so just be careful with this because there's some algebra here that we've learned, but we got to maybe recall. 2 times 2 is obviously 4, right? Radical 2 times x. Okay? You view radical 2 just like you would if it was like a 3. You would take 3 times x, right? You get 3x. So we get radical 2x. Okay? Now here's just the notation that we use. If I ever have a variable with a radical, okay, with my radical coefficient, we write the coefficient first. Okay, and this is the reason why. If I write 2 like that, is there a question of whether that x should, because this here, radical 2 times x, is different than radical 2x. Does that make sense, everybody? Where if I take the x and I put it out front, there's now absolutely no discrepancy, right? There's no confusion. Okay? You guys talked about in Algebra 1 that 3x and x3 like that, x times 3, those mean the same thing, right?
Yeah.
It's just the general formatting that we use with the number out front. Well, with radicals, because there could be confusion, we usually put the radical in the back. Okay? But this is still a coefficient. Does that make sense? Radical 2 is a coefficient. So that's about 1.4x. Okay? Now, I got to distribute. So what's radical 2 times radical 2 then? Radical 4. So it's plus radical 4, which goes down to 2. Good. So I get that. Now what do I do? Subtract 2. So it gives me 2 is equal to x radical 2, right? All right, everybody? Okay. So like I said, that really says, 2 equals x radical 2. Don't write this, but it really says like 1.414 whatever x. What would you do to solve for x here?
Divide by that.
You would divide by that number, right? But that number is that. Okay? So let's divide both sides by that. Does that make sense, everybody?
Yeah.
So right now we got x. We got x to be equal to 2 over radical 2. Now here's the reason why we don't like that answer. We've got a blue proportion up there that has x and y, and we've got a red proportion up there that has x and z in it, right? I need to replace x with 2 over radical 2, right?
Yeah.
Well, it's going to be kind of hard with doing the cross multiplying then with that number of 2 over radical 2. Let's rationalize and see what happens. I want to multiply by 1. So I'm going to look at this denominator. I'm going to multiply by radical 2 over radical 2. That's my 1, right? What's 2 times radical 2? It's just 2 oh, careful. It's 2 times a radical 2. So 2 radical 2. And I'll explain why that is here in a moment as well. What's radical 2 times radical 2? Radical 4, which is just 2. Okay? Now think about what's going on here. You have, if I had 2 times, let's just say 3 over 2. Can I rewrite that as 2 over 2 times 3 over 2? Or sorry, no, I'm sorry. Times 3. 2 over 2 times 3. 2 times 3 is 6, right?
Yeah.
Okay? And then divided by 2 would be 3, right? Can I take 2 divided by 2, which would be 1, and multiply that by 3 and still get the same 3? This equates to 3, and that equates to 3, right? The reason I would write it this way is because what's 2 divided by 2? 1. So do these 2's cancel out? Okay, so my x is radical 2. That's a better answer, is it? Would you guys agree that looks better than what I had in blue is 2 divided by radical 2? So now when I plug that in elsewhere, the algebra that's presented is going to be a little bit easier. Think about this, guys. If I take, just dealing with our radical work, for instance, I said 2 times radical 2, and I asked, what is that? Well, that's 2 radical 2's, right? Think about y. What's the coefficient out here in front of this radical 2? I could put an understood 1 out there, right? Could I put this right there? What's the square root of 1? 1. So does everybody understand that 2 radical 1 is exactly the same thing as 2? Okay. So now going off of our rules of multiplying radicals, is it 2 times 1, the outside times the outside, going to go on the outside, and then inside times inside, going to go on the inside? Does that make sense? Okay. There's a situation in here where you have to add radicals, because I think you get like x plus radical 2, right? And when I substitute radical 2 in for x, I get this. Does anybody know how to do that? Does anyone remember how to add radicals?
Yeah.
How?
2 plus 2.
Nope.
No, I didn't.
Because if you did that, so you're telling me you're going to get radical 4, right?
Yep.
Which would be 2, right?
Yeah.
Well, think about what this number is. It's 1.4 something. That one's 1.4. If I had 1.4 and 1.4, do I get 2?
No, you get 2.8.
Yeah, so this can't be a true argument, right? Those are not equal. Tyler, how do I do it? All right, so here's the idea, guys. The only time that I can, and this is going to give me 2 radical 2. I'm going to add the 1s together, and I don't do anything with the 2s. Here's your generic rule. If I have A radical B plus C radical B, that gives me A plus C. I add those together, and I put radical B at the end. So if I have like 2 radical 3 plus 4 radical 3, there's my A, there's my C. Add them together, you get 6, right? And then my radical 3. It's almost like adding variables. If I had like 2x and 4x, what would you write that as? 6x, right? Just now your radical 3 is that variable idea, that variable component. Notice what has to be underneath the radical. They both have b underneath there, right? Or both have 3 underneath there, or both have 2. If I ask you to add radical 3 plus radical 2, you guys know how to do that?
Yeah.
How?
You put 1 in front of it.
Radical 3 plus radical 2. This is the rule for adding all radicals. What's the rule have to say?
They have to be like.
The radicand, yeah, they have to be like terms. They have to be, they have to have common radicands. Do these have common radicands?
No, it's not.
Nope. So that is how we add radical 3 plus radical 2. That's it. Okay? As an exact value, you use the implied addition. Implied meaning when somebody reads that, they know they have to add, but I'm not telling you what that quantity is. Okay? 1.4 plus about 1.7 there. But we treat it as radical 3 plus radical 2 as a sum. Is that all right?
Yep.
Okay. I'm going to stop there. We might have time tomorrow to talk about some more of these if you want to. But again, I'm going to open up that math Excel. It's going to be due on Friday. I want to get into 7.5 a little bit here before the period's over.
Did you keep the some word